So now we're on page 3 of functions. Find the domain and range of each of these functions. So in this case, I'm going to highlight where these dots are because kind of hard to see them with blue on blue. That's too small. Okay, any others? I don't see any others, so I think there are not. Okay, so it says first find the domain and range of each of these functions. So when you have these points, then one tricky thing is you don't just look at the smallest value and the largest value and put them in an interval with inequalities less than or equal to. You need to actually write out all the values. This is like, I think something, a lot of you guys have trouble with the concept of discrete and continuous. And when you see it graphed, it's easier to see the difference between discrete and continuous. When you have dots, it's discrete. And when you have continuous lines, it's continuous. So in this particular case, we want to make a discrete set for the domain. So the domain is equal to x is an element of, and I'm going to list all the points that x could be. So it looks like negative 4.5 is the first, and then negative 4, and then, I'm sorry, it's not negative 4.5, it's negative 5, because this is between negative 4 and negative 6, so it's actually negative 5. So negative 5, negative 4, negative 3, negative 2, negative 1. Oh, and there's one at 0 too. There's one there. So there's 0, and then there's one at 2, and there's one at 4. So those are the values, and they're discrete values because they're all separated out, that are in the domain. What about the range? So the range would be the heights. So it would be like, it would be negative 2, 0, 2, 4. Tricky because it counts by 2's, right? So let's write those out. We're going to put negative 2, 0, 2, 4, 6, and 8. Right? Do you see how 8's repeated by 3 different points? But we don't write 8 3 times. We just write it once. Okay. So we're done with part A. So part B. Now part B is a continuous line. So in this particular case, we don't write it out with individual whole numbers like we did before. Now we need to write out an interval, basically pointing out what is the highest value and what is the lowest value, and saying that all the points in between are included. Do you see? All the points in between are included. So let's do it first for domain. So the domain of this, we're going to say x is, and we're going to say it's an interval, and x is going to range from negative 8 to x equals 6. So I'm going to say negative 8 less than x less than 6, because x is between negative 8 and 6. Does it include the values of negative 8 and 6? Yes, it does include it, because look at this point. It is including x equals negative 8, for example. So we put less than or equal to instead of less than. Okay? So that's an appropriate answer for domain. And for range, what we're going to do is we're going to look at the top y value and the bottom y value, looking at these endpoints here. And so the smallest value of y is negative 4, and the largest value of y is positive 3. So, and then we're going to put y inside an interval with less than or equal to also. Okay, because all the points in between are also included. All right, let's look at C. So this is a straight, or not a straight line, but it's a curve, and we need to pay particular attention to these endpoints because basically these endpoints define the interval. Remember, since we have a continuous line or curve, we are not going to write it out with whole numbers like this. We are actually going to write out an interval. So again, we're looking at continuous instead of discrete. So here the x values range from, looks like -7 to 9. So I'm going to say that the domain is, let's see, ranges from -7 to 9. And the range goes from 0 to 4. 0 to 4. Okay. What about D? So D, the x value ranges from here to here. So that would be, let's see, that would be -7 to 7. And I'm going to just make this bigger so that you can get a better picture of it. And for the y values, it ranges from -4 to 3. And that's the range. Okay, and let's look at this one, E. So for this one, the x value looks like this is an endpoint and this is an endpoint. This is a little bit tricky because look, there's this point here which is higher than one of the endpoints. So you don't just look at the endpoints when you have a curve. Sometimes the curves go up further or down further in between the two endpoints. So for the x's, you can just rely on the endpoints because you know, it's not going to go past these x values that are the endpoints. But for the y values, you do need to check all the minimums and maximums that are in between. So the highest point is going to be here, and the lowest point is going to be here. And you notice the highest point doesn't correspond to this endpoint, it corresponds to the maximum. So that we have the y values, the range, is going to vary from -2, which is the lowest point, to +2, which is the highest point because of the maximum. And the domain is going to be the x value, and it ranges from -2 to +1. Okay, so that's a little bit tricky because of this point here. Okay, so I think we can move on to the next section. Okay, determine whether these statements about the functions in question 4 are true or false. Oh, we still need to look at question 4, so I'm going to try to put them all in here. Okay, so the first question is, A1, the point -3, 2 lies on the graph of this function. So they're talking about A, and I'm going to check to see if -3, 2 lies on the function. So -3, 2 would be this point here, so it does lie on the function. Yes. I can write true, right? T. The image of x equals -2 is y equals 3. Remember, the definition of image of x is the y value that corresponds to this x value. So the x value of -2, does it correspond to +3? And so I'm going to check that. -2 corresponds to +4, not 3. So I'm going to say it's false. When x equals -4, y is 0. When x equals -4, y is 0. Yes, that's true. And let's see what's next. Oh, now they're going to ask us about b. The graph of this function crosses the x-axis at -2, 0. It crosses the x-axis here. And yeah, that is -2, 0. So that's true. The point 0, -1 does not lie on the graph of this function. So 0, -1 is this point here, 0, -1. Does it lie on the function? Yes, it does. It says does not lie, so that's false. There is only one value of x for which y equals -2. Only one value of x for which y equals -2. So there's y equals -2 and x equals 2. So there is only one value of x. Yes, so true. Now we're going to take a look at C. C is this one here. Is the one that's, there's C. When x equals 9, y equals 0. Let's see. When x equals 9, y equals 0. That's true. As the values of x increase, the corresponding values of y decrease. So that's going from left to right that we're talking here. And so when the x values increase, which is going from left to right, are the y values increasing or decreasing? Well, it's going down, so the y values are decreasing. So that's true. The vertical line x equals -7 intersects this graph once. So if we were to draw a vertical line at x equals -7, it would be right there, right? And it does cross the line in one single point at the end point. The line y equals 0 cuts the graph of this function twice. Oh, now we're looking at D. Okay, so now we're looking at D. The line at y equals 0 cuts the graph of this function twice. Y equals 0, remember, is a horizontal line, not a vertical line. So y equals 0 is this line here. Horizontal lines have the format y equals something. Vertical lines have the format x equals something. So this is a horizontal line that goes through the origin, and it cuts the graph twice. It does indeed cut it twice. There, like it cuts it here and here, right? So yeah, it cuts it twice. There are two values of x for which y equals 2. So y equals 2, again with a horizontal line. So y equals 2 is that horizontal line. There are two values of x for which y equals 2. That's true. There's -6 and +6. So that's true. And the last one for D, as the values of x increase, so do the corresponding values of y. So that means as we go from left to right, the y values increase. And not really true because look, don't they go down first and then go up as we go left to right? So we cannot say that they just increase. So that's false. All right, now we're going to move on to graph E. The line y equals 0.5 intersects the graph of this function twice. So y equals 0.5, remember, is a horizontal line, and it's at height 0.5, and it crosses the function just one time here, so it's not twice, so it's false. The line 1.5 intersects the graph of this function twice. So y equals 1.5 would be right here, right? Does it intersect twice? Yes, it does intersect twice, so this would be true. And remember, we're doing horizontal lines here, so we're not doing the vertical line test, we're doing the horizontal line test, which exists, but we don't do it in this class. But anyway, that's why it's okay to intersect twice. If it's a function, the vertical line test will not intersect twice, okay? But the horizontal line can. Actually, we do the horizontal line test in a later unit, okay, but not yet. The value of x equals 2 has no image. So again, what does it mean when we say image of x equals 2? We mean the y value that corresponds to x equals 2. They're saying that the x equals 2 value corresponds to no y value. And that is true. Look, if you look at x equals 2, there are no y values defined for that. So that is true. There is no image for x equals 2. Okay? Alrighty. I think that's it for this page. We're done with page 3.